So I chose to analyze the predator vigilance behavior in black-chinned hummingbirds, or rather the up and down motion of the head as the birds are feeding. And here we can see images of the birds. You've got your male on the left with that characteristic black chin, and then the female on the right, which is a little bit more plain. And in this next video, we're going to see a black-chinned male, and what we want to look out for is while he's feeding, he raises and lowers his head multiple times, all while hovering in the air, and we're going to examine that through the different levels of analysis. And just a real quick refresher, these are the four levels of analysis, and we'll start off with causation. Now, causation is really the more proximate definition, the actual mechanism by which the animal performs the action. And if we look at this video here, we can see that the bird holds on to the flower with its feet there, all the while hovering around in the air. Now, this behavior was studied in depth by researchers Su, Tin, and Yang, and they noticed that the way that the hummingbird flaps its wings is in sort of a figure-8 motion, which is particularly effective because it, in essence, allows the bird to stay in the air, which then means that it can fly away even at a moment's notice whenever it looks up and does spot a predator in the area. Now, the next level is development, another proximate level, or how the behavior comes about early on in life. And it can be deduced that this behavior is probably learned, that maybe the birds that have learned to survey their areas survive longer. And this hypothesis was studied by researchers Lonsett, McCormick, and others, who found that damselfish with more time exposed to predator cues actually survived longer than fish with no experience to predator cues, which means learning was a factor. In terms of evolution, our main hypothesis is the study of the inheritance of wider visual fields in sparrows than that of their predators, which was studied by Fernandez et al., and this can actually be applied to, well, all birds, including the hummingbird that we're studying now. Lastly, turning more to the ultimate level, my hypothesis on overall function and fitness benefit rests in the benefit of hovering, or the risk of predation versus fleeing, which is a loss of, well, food energy. Now, it's more beneficial in terms of energy for the hummingbird to hover and scan than to periodically flee to avoid predators, because then it's using the energy and it's moving away from food. And this was studied by Tinbergens et al. In the distance that lizard allowed predators to get, in, again, that predation risk versus loss of food energy, before the lizards ended up fleeing, that balance of benefit versus cost. And lastly, we have here all the hypotheses just in one place from the, again, causation, development, evolution, and function levels of analysis. And here's just short works cited, and thanks for watching.